Hey everybody, welcome back. Today we're going to analyze a non-organic compound. We're using all the spectroscopy techniques. We're focusing on problem 64. So if you have AR, mass, spectro, UV, and carbon and protons in the mod. Okay, before we jump about the problem, I want you to give you a general information or a few about the devices that we have. First, we'll start about AR. AR spectroscopy, this measures how molecules absorb infrared light. Different bonds vibrate at different frequencies, so we get peaks to tell us which functional groups we have, like OH, carbonyl, or CH even. Next, we have mass spectroscopy. That measures the mass to charge the ratio of fragment. It gives us a molecular ion peaks, so we know the molecular weight, and we also see how the molecule breaks apart. Next, we have the UV spectrum, or the UV spectroscopy. It measures how molecules absorb the ultraviolet range. This is great for seeing the conjugated system. So if you have a double bond or aromatic ring, they absorb a certain wavelength. Finally, we have carbon NMR and proton NMR show us the carbon and hydrogens are arranged in the molecule. Carbon NMR tells us how many unique carbons we have, and proton NMR tells us about hydrogen environments, like where they sit in the molecule and how they split. Alright, we will have this background that's applied to the problem 64, and we start with AR spectroscopy. Here we see the peak about around 3000, which indicates that we have before 3000 we have what they call it aliphatic, and after the 3000 we have aromatic. Okay, this indicates that we have aliphatic and aromatic. Okay, when it comes to indicate the information of AR spectroscopy, you will say that we have stretching of aliphatic, which is the before of 3000, and it's stretching of aromatic, which is after the 3000. Okay, next we'll check on the mass spectroscopy. The molecular peak is around 162. Okay, and the second one we have 147. We will subtract the molecular weight, which is 162, minus 107, which will get a 15. This indicates that there is a breakdown in the CH3 molecule when it comes to the compound, that the breakdown of a molecule happens on the CH3. Okay? Now, we'll start calculating the index of this compound. The rule of index indicates that 2n plus n divided by 2. Okay? The n indicates itself about how many carbons that we have. So, I will solve it here, which is 12 multiplied by 2 plus 2 divided by 2, okay, which is give us a 4. When it comes to index, there is kind of numbers that indicates what type of double bond that we have. For example, if you have 4, this indicates that we have an aromatic compound, definitely, okay, which is a benzene, okay, but lower than 4 we have a kind of a double bond, which is, for example, carbonyl or OH, so on and so forth. Okay, from this slide that we indicate that the unknown organic compound is an aliphatic and aromatic. Okay, and it has a kind of a breakdown on a CH3, and it's also a benzene. Okay, next we're going to have CNMR. The CNMR here, we have a proton coupled and a proton decoupled. Let's concentrate first on the proton coupled. The proton coupled has kind of 3 peaks on it. Okay? When it comes to proton coupled, different kind of a depth when it comes to CNMR. Like for example, when the proton decoupled here, when it indicates the peak here, we should minus from the overall of accounts that we have in the peak. Like for example, if we have here 1, 2, 3, 4, which is CH4, right? We should minus 1 from it, okay? Like for example, we're going to have here kind of CH3, and here we have 2 peaks, which is CH, okay? And here we have 1 peak, which is C only, okay? Next, we have a proton decoupled. Proton decoupled here, kind of range here we have that indicates what kind of groups that shows in the carbon NMR, okay? Like for example, when it comes to 0, kind of around of 50, which has indicates for me an alkane, which is shows here that we have an alkane compound here, okay? When it comes to also the proton decoupled here, when you have a peak around 120 to 160, it definitely indicates that we have a benzene here. This, like, it's kind of a thing that carbon decoupled only ensures or give me like insurance, the information that I have from the AR and mass spectroscopy is already correct. That's only making sure that I am going to the right path, okay? From now on, if you have a different kind of information from the AR mass and then you go to see NMR, you have 2 different kind of information that's indicate for you that you are going in the wrong path, okay? The information that you have here, it should be goes as follows, like not has a conflict or anything that is different from each other, okay? So let's review here on the carbon NMR. We have CH3, CH, and carbon alone. We have alkane and benzene. Okay, next we have H NMR or proton NMR. This only give us where exactly do we set or arrange our, an unknown organic compound. Before like going to the H NMR, we should kind of, draw the compound based on the information that we have from all the devices that we have, the AR, mass, and CNMR. Some of the information that we have from all the devices, for example, like for first we have from the AR is just aliphatic and aromatic. Sorry, it's kind of slow. I don't know. From the mass, we have, we call it breakdown in a CH3, which is indicates of 15, okay? And from the carbon NMR, carbon NMR that we have CH3, CH, and C. We also indicates that we have a benzene and alkane. Sorry for the handwriting, I know, but it's kind of hard for me like to explain it in a PowerPoint thingy. But whatever, all the information here. So from the hydrogen carbon here, this kind of thing here indicates to me that different parts of hydrogen or proton in the MAR that's indicate. His is the shielding and his the de-shielding thingy. When it comes to the shielding part, this indicates for me that there is no kind of what we call it withdrawal molecules that on the compound itself that has taken it to the de-shielding part, okay? Also, the HNMR indicates that here, when it comes to 2, 3, when the line or the peak itself comes from the 2 to 3, it is indicate for me it's an alkane or aliphatic compound, okay? So when it comes to drawing of the carbon, index indicates for me, which has already like 4 double bond, which indicates for me that there is a benzene in the compound itself, or cyclo shape, okay? And then we already have 12 carbons and 18 hydrogens. From the cyclo itself, make sure that you have a double bond in it, okay? Because we have a benzene, not only a cyclo thingy, okay? this indicate for me we already have a benzene. And in the benzene itself is 6 carbon and 6 hydrogen, which is we already left from the 12 carbon is 6, and the hydrogen is about 12 maybe. Okay. So let's draw it in a really, really correct way. Let's go back to the CNMR. The CNMR indicates for us that we have CH3 and a CH and a C. Okay. The CH itself has here in the benzene itself. Okay. And we only left that we have is a CH3. It's already like confirmed us from the mass spectroscopy, which is CH3, okay? So we're going to draw a CH3 for each carbon molecule that we have in a cyclo or in the benzene that has a CH3, sorry. Hold on. Okay. CH3, 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 and here CH3. Okay, let's confirm the shaping of the drawing of this molecule is correct. Okay, let's go from the first. The AR itself has, as we already said, that we have in the shape that we have already drawn is aliphatic and aromatic, which is the benzene and the CH3, okay? From the mass, the cut has done for the CH3 which already like here. Hold on. Here. So we have a cutting that happens in the mass spectroscopy is in the CH3, which is, we already have a CH3 here for each the compound, okay? From the CNMR itself, we have CH3 and a CH. We already have it in this compound, which is CH out on the cyclo itself, or in the cyclo, or the benzene. Okay, the second thing, and the carbon CNMR that we have indicates for us is a benzene, and already have in the compound, and it's a 0 from 40, which is an aliphatic. The proton NMR indicates for us that the compound itself is in the shielding part, which indicates for us there is no withdrawing or halogens or something that would drag it to the de-shielding part. Okay, this all indicates for me that the compound that I have drawn in this in this slide is already correct. Okay, thank you for watching this video. I hope you learn or understand that the information that I have for you. Hope you a really good day.